I think.
Lovely to have you, Pierre. Thank
you. Yeah, well, thank you very much. A big thank you to Acting for Water, and yeah, special thank you to Katarina Zu for organizing this. It's a pleasure to present to you today what we do at Solaq, what we have been developing over the last quite a number of years by now, and where we're going, where we're taking this in the future. So, quick introduction on my side. My name is Pierre Benouri. I was born and raised in the Middle East, specifically Kuwait, one of the very water scarce regions of the world, but where they just desalinate everything, so it's not very visible on the ground. But I'm French by nationality, although I was born abroad. I did a bachelor's in environmental science in Nice, France, and I shifted that towards geology and geophysics. I love nature, so that's where I was. I moved to the Netherlands to study energy science, to be more actively participating in the role of shifting and molding our future, energy-wise, but also sustainability-wise. And on my path, I was working at NGOs and I wanted to take even more concrete action. And that's where I encountered Solaq and our CEO, Ruben Moore. And we discussed back in 2020 the projects, what we're capable of, what we're thinking of doing. And this is what brings me here today. 4 years, fast forward 4 years, here we are. So I think, part of I think you all know here at Acting for Water and the water issues around the world, we're still at a status of where 1 in 4 people lack access to safe drinking water, basically, around the world. And this is only worsened. And this is a big issue that needs to be solved. Not enough work is being done to tackle this growing problem, but we've taken it upon us here at Solaq to at least make an impact and tackle this issue. Because many areas on this planet, often the only way people get their water in water scarce regions is by water trucking. You can generalize this a bit by doing water transport. You have situations that I've found that in Colombia, for example, they don't use trucks, they use a train. There's a train going through La Guajira Desert, transporting thousands of cubic meters of water to remote communities every month. You have even situations in Europe, closer to home then, because I'm based in the Netherlands as well. And Europe, we often think that we're a bit immune to this, but France, Spain, Italy, Greece, they all have a lot of water issues, especially during drought seasons in the hot heat of the summer. And you have a situation in Catalonia in Spain where they even ship water by boat from France to Barcelona. And that is, of course, something to keep in mind of. But the key issue while we're looking at water trucking here, this photo was taken, for example, in Brazil, where we're active. A water truck is filling up its tank from a reservoir/lake. The issue here is that it's really unreliable. The fact that if you talk to communities on the ground, they have to call these water trucks to provide their households with water. It doesn't always, sometimes it's scheduled, but even when they do call them, you have situations where they expect it tomorrow, but the truck doesn't come. The truck might not come for another week. And then it occurs like that, and that can be a grand issue just in terms of security and health. It's also expensive and polluting. Expensive being and polluting both go together because the distances these trucks have to drive sometimes are immense. You have situations where they're trucking water for 200 kilometers away. And that is quite an issue price-wise, but also fuel-wise, pollution-wise, because these are diesel trucks and a lot of emissions go into transporting this water from one area to another. And most of all, it's unsafe. Basically, sometimes no one really knows sometimes where the water is coming from. Rules are not always followed on where these water trucks should be picking up water from. And although the water is supposedly and said to be potable water, it often happens that they are delivered water and it's brown or it's contaminated, and then they can't drink it. And then they're just back in this cycle of problems, and it's just basically unsustainable method, ecologically, economically, just altogether safety-wise. So what we have doing, this is what has brought us. Because basically, if you think about it, if you can breathe, that is the key goal. Because at any given moment, there's more water in the air than all freshwater bodies on the planet. And the key thing we did here is thinking of a new way of decentralizing the water system and having a way to have water sourced locally without having to move it or anything, and giving access, well, basically, a new source of water security anywhere. And of course, we have to make this scalable, we have to make this sustainable. And so, without further ado, this is what Solaq has been developing over the years. So this is air-to-water technology, also known as atmospheric water generation. And we basically take water molecules directly out of the air around us and produce drinking water. And how this is done is that, but basically I forgot to mention, is that the key point is that it has to be done without any existing infrastructure, if required. Some places have infrastructure. I just want this type of device, but that is something to do. Then you have very little maintenance required. So no staff needs to really be present on location, and we can monitor and control everything remotely. And I mean, this is not a picture, keep that in mind. This is a render. So this is a vision of what we're working towards. And it's the intended full-scale system. And full-scale is variable because over the last months, even since my previous presentation at Acting for Water at the CEW in Leeuwarden, our engineers are very hard at work changing designs and optimizing situations and thinking about other ways to do this. I'm pretty sure the last time I presented this, it was a different render. But of course, so the full-scale system here, we can see 3 absorbers and 1 distillation unit. I'll get into this very quickly later. But what sets us apart is the ability to use thermal energy and not only electric. The fact that we can go down to quite low humidities, so we can really go virtually anywhere in the world. It's powered by the sun. So as I said, either PV, we can use PV, but our focus is solar thermal panels. So the hot water plates, which are cheaper and most commonly found, you can find that kind of anywhere. And to keep our system modular, so we can add, we can modify, we can add components, we can double the size of the absorbers or the amount of them, and to make it off-grid, of course. So it doesn't need any infrastructure since it's solar powered. And the whole goal here is now we're, according to our models and what our calculations show, we're producing about 2,000 to 6,000 liters per day. But of course, as I said, modulable, we can add absorbers, which will produce more given the needs of the use case. Oh, here we go. This is because, like, for example, what we've been doing, you have a unit, single absorber here, which can produce 750 to 2,000 liters, depending on the climatological conditions associated to 1 distillation unit. Or you can have what we call the full scale, which is 3 absorbers and a bigger distillation unit to process all that water, of course. These are the latest renders we have. I think the key point that I'm trying to get to is what we do is water security. By being able to produce water anywhere, we are giving communities the sense of water security because they don't have to have this panic of where the next water shipment is coming from because they don't have groundwater. This is the situation to keep in mind. They don't have groundwater, they don't have surface water. In situations where you have sustainable options to retrieve those types of sources, those might be better options, just for many reasons. But there are often places around the world that do not have those options, and so we provide them with a sense of water security. And because our technology is not optimal, it's not super high tech. It's not all organized to be high tech and very productive. We have really optimized it to be reliable, sustainable, and most of all, produce safe drinking water because the water that comes out is pure H2O, which we then remineralize in the system itself to make drinking water. But the key component in many of these places is to keep that water affordable. I mean, we are aware of other AWG technologies that have gone completely high tech. They can produce good amounts of water, but the price of their system is just absurd then, which raises the price of that water and makes it inaccessible to the solutions we are aiming for. Of course, I forgot to mention at the beginning, I will going through this as a lecture, but of course, we can keep this a bit as a discussion as well. If you have any really immediate questions, you can raise your hand and we might address them. But the key point, what I wanted to say here is compared to where we're actively going, which is attacking the water trucking market, we're already in many cases much cheaper than trucking that water. And that is already a key component in our vision for the future. So for the tech side, I am not an engineer, but of course I have built the system with my bare hands as well in the last 4 years. And so I can, of course, explain how the system works. It's fairly simple. So, I mean, I don't know if many of you know, but there are already quite a number of AWGs, so atmospheric water generation technologies out there today. So it's not crazy new, but we do have a specific part of our component which is innovative and which puts us and sets us apart from the rest of the group. But basically, how our system works, we have three main components. We have an absorber, a regenerator, which can also be called the distiller, and the energy supply. So the core of our system is the absorber. That's the proprietary tech, and that's where we get the water out of the air. Basically, we suck in a huge amount of air into the absorber, which passes through it. There, we bring it in contact with a hygroscopic fluid, which is basically a fluid that naturally wants to desaturate itself and take water molecules out of the air. We have a special way of getting as much contact as possible with that fluid. After this process, the liquid has been absorbed into the working fluid. Then we pass that to the regenerator. So that working fluid, it's a continuous process, but that working fluid then moves on to the distiller, which is the regenerator. We distill this at a temperature of about 70 degrees because we work under vacuum, enabling us to use the solar thermal panels, very cheap, not even these really expensive high temperature ones. That enables us to get the water out of the working fluid through distillation. So we capture that vapor, which we then condenses into pure H2O. Once we have that pure distilled water, we just remineralize it, and there we go, we have pure drinking water. Of course, I'm assuming there might be some questions here, but we'll come back to this, of course, afterwards. And the key point is, since we're using a vacuum distillation, we don't need the amount of energy difference than a normal distillation process is considerable, and that enables us to use thermal energy instead of electric, keeping us flexible and cheap on that manner. And so what sets us really apart from our competitors in this field is that most of them, if you do casual research, a lot of them are currently using cooling condensation, which works a bit like an air conditioning unit. And that creates quite a high cost of water. Usually the humidity threshold is quite high, and they really need a lot of electrical energy for absorption. We've seen cases, even in Brazil, where they've tested these over a few years, and although they produce good quality water, in the end, they weren't suited for the environment because the humidity threshold was too high, and the electricity needed to attain then, when the humidity is low, a lot more electricity is needed to cool it more. Basically, it was too expensive. So we are using a process called wet desiccation, which involves, as I mentioned earlier, a hygroscopic fluid. So this is a saturated fluid, nothing special, calcium chloride, and it's so saturated it naturally absorbs molecules of water. And that enables us to have a low cost of water. We can function at lower humidities than our competitors, and we use thermal energy for regeneration. As a side note, we can use electricity if our use case really wants that, but we rather use thermal. It keeps us more efficient. All right, so in 2022, this is our first small-scale prototype in Brazil, in the state of Ceará, in a little place called Quixeramobim, where you have hundreds of communities that are out of the grid of the pipe network and who rely on water trucks or other types of water transport. What we did here, so we developed and tested this small-scale prototype, which is at this point was 1/10 of the scale, consisting of one absorber and a small distillation unit, all packaged into one container. And what happened here is that we had about 200 liters of production per day in the height of the dry season. Because in this area, it's called the Caatinga. It's very specific to the Brazilian Northeast. You have a wet season and a dry season. Wet season is usually fine. A lot of people collect rainwater. But at the dry season, things get chaotic and water runs out, and the water truck system has to run provided by the Brazilian government. They really have to function through it. And we did a lot of experiments. I was there working in the field. It was a lot of fun. But basically, we proved the working principle of our system and also validated the assumptions and simulation in terms of the production. because this is what we got. So keeping in mind that Quixeramobim is one of Brazil's driest places, with relative humidities reaching normally low as 15%, we were able in the driest month at least to get to about 1,500. But keep in mind, our engineering has changed since then. So this is an old graph that I'm still showing you. But basically, this brings us to at least a certain level of purity throughout the year. And I mean, our focus right now is on drinking water for communities that are really in need. And that is basically our first focus is wherever water trucking is being used to provide water to these people. But there are many options out there with our system. One interesting one we found recently is green hydrogen, for example, because the heat emitted by the electrolysis process of green hydrogen is basically the same amount of heat that our system requires to produce water. And what does hydrogen need? They need pure water. So we are actually able, and in conversation with some potential projects, to associate our machine in a circular manner with hydrogen production. But we also have, of course, schools, hospitals, tourism, emergency situations where we can easily deploy our system to produce water on site in a couple of, like maybe a 1 day max of installation, high-tech agriculture, and industry. Because as well, same with green hydrogen, a lot of industry that we've been looking at who will use a lot of water have a lot of heat effluent that can be harnessed. And the whole key here is that, well, sadly, the potential worldwide impact of our technology is quite big because water scarcity is only growing. But our main focus at the moment, and where I've been actively going in the last few years, is the northeast of Brazil, because there you have a country of about almost 215 million people. 35 million of these people lack standard access to safe drinking water, mainly in the northeast, which is the usual less developed area of the country. And the thing is, we were initially investigating other places, but Brazil on this point is actively, like proactively trying to find a solution before the situation gets worse. So they're actively looking and trying to research innovative ways to provide their communities with water, and because they don't have time to build the whole pipe network yet. And of course, that's surprising because even to me, when we started looking at Brazil, it's also known as the country with the most water in the world, but you have situations, it's a massive nation, you have situations like this. This is when it gets more specific, is the fact that water trucking program, which is a government federal program, but then divided by states. But basically you have 1.6 million people that rely on receiving about 20 liters of water per person every day by water truck. And some places do this only in the drought period, but some places do this all year round. They're all year round going with these water trucks. And of course, we don't need to get into it, but there's a lot of corruption and political power plays being played out with these water trucks, which is causing chaos. If you're interested, there's a movie called Bacurau, Brazilian movie, which you can watch. It'll give you a bit of insight on that. So this is us, what we've been doing the last few years. Our upcoming project where we'll put the machine in 2025 once it's developed and run it all throughout 2026 is in the place of Quixeramobim in Ceará. This is a community of about 200 people, about 40 families that still have major issues with their water trucking. They're about an hour and a half from the closest paved road. So keep that in mind. They're very isolated. And we will be putting our system in the background of the leftmost photo behind the people here in that field. I know it looks very green. If you look at it now, it's like, oh, it's very green. There must be a lot of water. That is the wet season. If you come there in the dry season, it is all brown, completely dry. I can present to you our team because it has been changing and growing in the last year a little bit. So, I mean, we have our founders, so Ruben Moore, Peter Soleveld, and Evert van Voorthausen. Dr. Evert van Voorthausen is the master engineer. He is 83 years old, I think, at this point, but he is our master plan engineer behind everything. He has the creator, the main idea, and he still works in the field with us. On that machine I showed you in 2022, he was there with me fighting the spiders and scorpions, and we were working on the machine all throughout the night. We've been growing, of course, a lot on the tech side as our engineers are getting we're getting a lot more engineers to produce the system, get it all ready for the first full-scale demonstration. And I am here at the bottom right, along with Bob and Sabine on the business side, researching use cases, potential places where we can help communities in need. That's our new office. If you'd like to come visit us, it's Keienbergweg 35. We have just had it for a couple of months now. It's our little fun team. This was taken last week just to keep it up to date. But I could have presented this earlier, but this is the technical timeline. So the ideation by Avert started in 2016. It has been exploratory phase, a lot of R&D prototyping that Ruben and Avert conducted in their home in Groningen. And it's been a lot of work since then. I joined in 2020. We built this prototype at 1/10 of the scale, sawing pieces of aluminium and everything together. I had the prototype in Brazil in 2022, tested it for quite a few months. And this is where we are now with the development of the full-scale system, which will be shipped to Brazil 2025, mid-2025, and then tested for at least 6 months to a year, with hope of market introduction by 2026. And I'm very proud to present that we got recently in September about 1.4 million in funding to get us to that next level. And that will allow us to develop this full-scale system, get it there, test it, and will help us get to where we want to be, which is the vision of providing water security everywhere. Now, but I have to mention though, because of course, Katarina, you did talk about this. I don't have a slide for it, but we do emphasize, of course, citizen engagement on this. I mean, one key thing when we work with, when I go to places, is the key point is NGOs will ask me, but how does it work with the communities involved? I mean, because you have a system that can be controlled and shut off and all this and that from a remote area, because keep in mind, it's a self-sustaining system that we will produce water. Now, the key point is that we are already collaborating with local stakeholders. We're engaging with them. We're planning for civic monitoring. I mean, this is the vision that Solaq holds to heart. So we've already been conducting research regarding which local organizations are able to monitor and conduct the low O&M that we have to operation and maintenance, because there's barely any, but of course there is always a little bit in terms of replacing pumps, replacing some filters, maybe even just casual operation maintenance to move some parts. That is key. And also the remineralization process, which probably has to be replaced every 6 months or so. And so the idea really is that the communities receiving the water get a sense of ownership of their new water source. That is key, because it's theirs, it's locally produced, and that is their new source of water security. So the organizations we're in touch with, they actually actively teach citizens and the communities themselves, so the people involved, how to care for this new fountain from the air, technologically, but also organizationally. And so we plan to collaborate directly with the communities on the ground that receive the systems in this way. So for now, there are individuals, these are the individuals that are living in these off-grid communities in Brazil that rely on water trucks. We also have to ship the people who perhaps work on the water trucks, who drive these water trucks, to actively take care now, get involved with these off-grid decentralized systems. And of course, one question we've had from the communities themselves is, and we leave it up to them, is how they decide or how they wish to manage the locally produced water. I mean, we have one project in Brazil where they're thinking of just having a giant tank cistern where our machine will produce the water stored in there, and everyone can come get the water they need from it. But of course, that is different from the water trucks who deliver water usually directly to the households. So we have another project in Brazil in our portfolio where the project would be to install actually a microgrid from our system to each household. But then of course you have to control, that's up to them as well, how much water is allowed to each household and things like that. So these are all up in the air kind of questions that we're still molding and thinking about. And on terms of citizen advocacy, it's really, I mean, at this very moment, like for example, this was yesterday, I think it's still today, our partner in Brazil, in Ceará, called FUNSEMI, which is the Meteorological Institute of the state of Ceará, who are planning we've done the previous project and concocting the next full-scale project with. Well, they were actually on the field just the other day and today, with other researchers who are conducting a 2-year project on the health and other socioeconomic benefits of our atmospheric water generation system in these small off-grid communities. So they are choosing a couple of sites. Of course, there's the site where our system will be placed, but they're conducting surveys and introducing methods of monitoring water quality in the existing cistern tanks that they have, but also gathering information of how it would change their lives to have water readily available anytime for them. And I mean, the key thing, another topic, I'll just end on that real quick, is the question we get, well, is would it work if we give them water from the air? People might think that we are giving them as well unlimited water from the air, or people will change their water habits because they have this idea that, oh, water is being produced 24/7. So actually their consumption will increase, their water use will increase, and that will just bring them back to the same situation as they were before. So that is also a key point that we are aiming and molding to. And I say molding to because, of course, we don't have any project on the ground yet. So this is the vision we have and what we're trying to put in place with our local partners in target countries. So key is making people aware of how sustainable water solutions allow for better nature conservation. For example, there are cases where there is groundwater, but it's so overused and it's not replenished in time, and that destabilizes the environment. But also water trucking, how they're shipping water from one reservoir to another reservoir, sometimes, as I said, 200 kilometers away. That is a whole environmental change of shifting water from one place to the other. So that's key. But also very important is having people be aware of their own water use, and consumption, and try to keep it not as low as possible, but keep it as sustainable as possible, even with our AWG system. And the key point also with this water truck is the water truck system has quite a strong hold on politics in Brazil. So it's also getting citizens engaged to wanting to have more of this decentralized system with this atmospheric water generation. And so lobbying the local governments to make this move away from this current status quo, and which is often problematic. And if you do a bit of research, you'll see that it's held in very different obscure ways. But thank you very much for this presentation time. I think I'm right at 30 minutes. I think I went a bit further than I was expected. But if you have any questions, you can see my email right here on the screen. You can scan our QR code. I think it leads to our website. And of course, if you have questions right now, the floor is open. No. Yeah.
Thank you very much, Pierre. Maybe I can supervise the question part. I think who also, by the way, from Web to Learn, who invited you for giving this talk, so also thanks to them. So Katarina, you have a question.
Thank you very much, Pierre, and I would like first of all to thank Jordi for having invited you back in July. Coming from the educational and learning sciences, I was fully unaware of the magic on water management. I will not ask you the most usual question you normally get, like how much does it cost? I'll ask you, is the installment or the technical equipment possible to be co-constructed or co-produced with citizens or students or university students to make this dimension of citizen engagement more real and also more beneficial financially for you, so not requiring you to invest all the infrastructure locally?
Yeah, no, great question. Of course, we get this, don't get that specific question that often, but we do to get around that. But I mean, the key goal, the key vision I myself even have, but as Solaq as a company as well, is The main proprietary technology that we have is the absorber component. It's actually a very specific part of the absorption component. So whatever is the energy production and the distillation, we're actually actively, I was in a project for 6 months looking for local partners in each target country. So ideally, of course, from a financial part, but also from the engagement part, we would much rather have those be readily available and produced in the place where we're going. So especially by students, we've done that already, projects with other students. And so in Brazil, for example, it's definitely not for the next system that will be placed there, the full scale, but the longer term vision is to have the distillation and the solar panels directly there with local partners on site. I can imagine the solar field being constructed there with the local citizens and engaged in that way. The distillation part, I think that's quite technical, so I don't know if that can be produced directly on site, but at least in places in the country that we're aiming for. And the absorber unit, from what I've heard, that will still stay in in-house production for a while because that is our main core component. But I can imagine in a future, in about maybe 3 years, 3 to 5 years, I hope that is the vision at least, to have multiple production facilities in other places where we involve local students, local engineers, local workforce, local engagement everywhere. But we also have to keep in mind that our first target places are really these off-grid communities who live a very rural lifestyle, which of course are adaptable. We're training them to do things, but it's also a whole other program, which at this point in time, it would be difficult to say if we would have the resources to do that ourselves. But the key point, and that's the key thing we do emphasize, is forming partnerships with organizations in target countries that are able to do so. And so, example case in Brazil is FUNSEMI and CESAR. FUNSEMI is the science part, but CESAR is a real local organization that provides and works for rural water supply in the northeast of Brazil. And they actively work with people on the ground to get that going. I hope that answers your question, Katarina. If you
Yes,
have any other...
it's great. Can I, Martin, if you allow me, can I ask another question? Thank you. If, let's say, some parts cannot be produced on site, this is fully reasonable, could the citizen do some do-it-yourself things, or for instance, to assemble? Because I understand that you talk to people not in, in rural areas, right?
Mm-hmm.
Or who could help in assembling the infrastructure that you will bring in, or to do the monitoring through, for instance, a real-time function of their mobile phones, for instance, an easy application to monitor consumption at that long tail of the use.
Yeah, no, that definitely. I mean, like, I think a lot of parts available locally, first of all, a lot of, like, the parts that we expect, I mean, we expect a lifetime of 15 years of this system. The main parts that will need replacement are usually small valves or pumps, which can be found in most countries. So those are, like, a lot of operation and maintenance in that sense is aimed to be involving local engagement and directly on the ground. The idea is not, we don't want to send people all the way from here from the Netherlands to these isolated places just for that, of course. The whole program is that. In assembling as well, so keep in mind, we have built this system to be the least complex possible. So the whole goal is, if there is operation and maintenance, to keep that very accessible. And monitoring, definitely. Like the monitoring, we have not concocted an app or anything yet, of course, but there will be, of course, scanning of the climatological parameters, maybe when to turn off and on the system. but also, of course, the water production. Of course, I think I do clearly imagine, and that is what we're working towards, I'm pretty sure, is having the community in mind that has the system. They will have a screen showing how much water is being produced right now, what is possible, what is the storage level, can they go get this water, what is the state of this water. There will be a lot of that.
That's fascinating. Thank you very much. Martin, over to you.
Thank you. Yes, there's also a question from our side,
Yeah.
from Jordi.
Yeah, thanks, Pierre, for your presentation. I want to ask you about your business plan, because I mean, I know the story of Solaq from the very beginning, and still I have questions about the business plan, because when you, for example, in Brazil, you go there, who is going to buy your equipment directly? I mean, are you talking to small city halls? Are you talking to water companies? Are you talking to particulars? How it is?
That is the excellent question, because that's also the cloud of ideas we are in right now. So right now I can say we have identified 4 different routes in Brazil that we can take. Because it's been, of course, a long journey, and it's been a key point is always like, okay, people get very excited, they see potential, all the rest, and then it goes always down to like, okay, who is going to pay for this system? And that's always a very tricky question to pose, but that is a final and very solid question. The key point is there are, of course, a few options, but what we've identified so far is first you have state level. It could be state level, like a governor, the governor in question, the actual state who is trying to place this. We put them under the government institutions. So I've been in talks with some governors, for example, of the state of Minas Gerais, the state of Paraíba, Piauí. And of course, then that trickles down to having then a conversation with, specific mayors of specific small towns or municipalities who have the issue. And there are some cases where they will be the client, but there are some other states, because Brazil is a bit organizationally, state by state, can be quite different. Another client we have on the radar is the public water utility. So the actual public water utility, which in Brazil can be semi-privatized sometimes, they are actively looking for solutions. They cannot build the pipelines right now, and they are actually the ones who are paying for the water truck system operation right now. And so they have the incentive, and they see the solution of replacing the water truck system or whatever they're using right now with the water trucks with our system. So they're another option on the business side. But then we've also identified is the private water utilities in Brazil. I like to kind of shy away from this for many reasons, but it is an option because you have a big rise of private water utilities in Brazil who are actively competing with one another, and they would also like, basically we provide them with the technology that would allow them to provide rural places with water. That is one option for them. The other last option is the ESG route, because ESGs are coming in strong and a lot of companies are looking for ways to be more sustainable, but also give back to communities where they might be taking water away. But these two are very on the draft level. There are two options. Our main focus right now is still dealing with public water utilities as a potential client. Second is directly the government, local governments, so municipal level, but also state level of the states.
Yeah, and Pierre, did you ever consider to open a company, place the device there, and make the people pay for the water only?
Oh,
and then you,
yeah, I mean, yeah, go ahead. Sorry.
Yeah, did you did that? Did you consider that? Because the only thing I see with your system is that either you need to connect it to an existing grid within the city, if the houses are connected, or the people needs to walk to your place, picking up the water in a bottle, and like in I don't know, 40 liters or 20 liters able to be carried for a person, and then bring it home. What is the status of the population there? Is like they have a grid that all their houses are connected, and therefore you need to join forces with the owner of that grid, or people is walking to the water truck and pick it up. How do you do it?
Right now, like in the communities in question that we have identified, there are basically the water truck comes and there's no grid. First of all, there's no water grid. Second, the water truck comes each household and delivers an amount of water to each household has a tank, usually on the side of the house, and they will deliver water directly to the house. So that is a question we have to the communities, for example, because of course our idea, we will put the system in one location, the most efficient location. Try to maybe the closest distance to most houses, but also not too close because of technological reasons, and we don't want to make it can be quite a loud machine, perhaps with the fans rotating. We don't want it to be very close to the habitations. So one key thing is that's why we're in discussion with them. Because right now we have basically 3 projects on paper, but 2 were very different. One being that they want our system to produce water into a cistern, and then they will see from there. They want us to put all our water we produce into a tank, and then they will take care of it. It's not very clear. The other project is they want to build a small microgrid, which this is the public water utility. This is one of the client is the public water utility. So instead of building a huge grid to bring water to the community from the main grid, they want our system there and make a small decentralized grid that will go to each household, about 40 households. So this is what we've been seeing so far, and that's actually the way we think about it, because I think that would be a better solution, in my own opinion, because I just see that difficult for these communities who get water from water trucks directly to the house. If we then make water in one location and they have to walk or take a little motorcycle with a jerry can to go recoup, it's not the most, I mean, it's still water 24/7 whenever they need it. So that's already secured. It's at least better than water trucks in that sense. But I can imagine, if I think about it very quickly, that these communities might, like some individuals might not like that idea of having to go pick up water from a certain location.
Okay. And in these communities you have been working, what is the average distance of the water trucks that they need? Because I guess they, I mean, the picture you show is they were abstracting some water from the surface water, and they would put it in the truck with no treatment whatsoever. So it's like surface water directly to your mouth. That's not safe, in my opinion. And what is the average distance, or where do they go? They go to the last point that the grid can guarantee a quality of water, and then they truck it to a decentralized town or isolated town. How does it work?
It's actually a bit of a complicated process because the actual operation water truck is done by the federal government in Brazil. And the army takes care of this. And usually the army will say, okay, we have identified of reservoirs across the state which are authorized to extract water from. But if you look at the reality on the ground, a lot of these water trucks, to make it just more efficient for themselves, will just take water from kind of anywhere, which are not authorized or not supposed to take water, and maybe unsafe, as I was saying. And the distances then, they vary a lot, because also keep that in mind, like I was working with researchers there in Brazil, and these reservoirs change. Maybe one year it's this reservoir, and then the next year it might be another reservoir, because that reservoir is now low and they're going to go shift to another reservoir. So the distances change all the time, but we've seen distances from a mere like 5K to 200K, even 300K in some places, where the technical army authorized reservoir is so far, they still have to provide water there. But then what happens in those cases, very likely, is that the water truck will actually not take water from there and will just make it more efficient for themselves by taking water from somewhere else. I mean, we've heard many stories in Brazil, even with the GPS trackers that are modified and don't actually count. They don't deliver to places, but the drivers get paid as a function of how much they drive. So then they'll just put the GPS on a motorcycle and just go around a little bit. and then not deliver water at all, and then take that water and sell it to someone else. So it's a whole mess.
Okay. Yeah, thank you.
Are there any other questions? Because I also can ask a question myself. But first, I'd like to give you the
Can I ask a question?
Yes. The camera to you.
I'll lean a little bit forward. Thank you for your presentation. What I wonder is, right now, if I get it, if I get a clear picture, Solaq sets the whole project up themselves, right? So they're from beginning to the establishment of the I don't know, the production side. You're there, but is there gonna be a point in maybe 10 years or something that Solaq is just a producing company of the production plans, or is it always like you will be there for the whole project cycle?
I mean, that's a vision for the far future. Like I can say that for the short term, until we really definitely have what is the word for this? But yeah, partners on the ground to really relay everything. I mean, until we get to that point, we will have to be involved with the project start to end. But I can imagine, of course, as many companies will go, we will be the producers of even just the absorber component, have a partner for the distillation, and have local partners scattered, or people who manage the electrical part and everything in each target country or each market. And so, yeah, we will only have to deliver the absorber part and perhaps the distillation part, because we have other plans as well. We might make our own distillation optimized for our systems. So, I mean, this is a very far future question. Like, we're still a startup in many directions. And probably that's a better question to our CEO, Ruben Moore. So I don't know. But I think we're open to ideas.
Any other questions?
Yours.
Then my own question, but maybe it's a bit technical, so I'm not sure if you can answer it. But let's see. I was wondering, so you apply this technology mostly in relatively dry regions. So you mentioned down to 15% relative humidity. I was wondering what percentage of the humidity you actually capture with your technology. So what is the relative humidity of the outgoing flow, more or less? Is it close to zero, or is there still maybe potential for your technology to extract more if you are able to develop the technology further?
Good question. I mean, it's not zero. It's definitely not zero. Because it's also the way the air passes through our absorber, we could make it zero. Could make the outgoing effluent down to zero. But I remember when talking to our engineers, and even on the first, keep in mind, I'm not in touch with the latest developments. That has gone full engineer side, and that's not my background, so I know what they're doing, but they're taking it to another level, which was back in 2022. I was fine with that. Now it's at another degree. But the key point is I remember that it's basically drying the air. The air gets dry, of course, progressively as it moves through our system. But it gets to a point of simple efficiency of the length of our system and the drying of the air. It's just that, there's no point anymore of actually decreasing it further. It's just less efficiency on the size-wise and energy component. But it's not zero.
Yeah, I imagine that you could extract this last little bit of humid of moisture, but then there's a lot of extra pumping of flow, airflow for the system, and then there's an optimum in how much you want to.
Exactly. Like also the amount of fluid we would have to add more to get those little percentages out. Not really worth it, maybe. But I mean, and also the humidity, yeah. So we don't bring it down to zero. I think we could, but it wouldn't be efficient to do that.
And if you would apply this technology on a large scale, do you think that there's on the whole ecosystem, you remove moisture from the air. It doesn't have the potential to influence the local climate as well? Or
This is
huge scale in order before that has an effect?
this is the question I was expecting first, actually. This is always usually the question we will get. And of course, we have to keep in mind there's like 10 kilometers of air above us at any given moment, which is not, it's a kind of continuously moving. There's no vacuum in nature. If you take away something, it immediately melts out more or less. But at the scale we are working at, like there's no huge effect on the surroundings. Now, if we were to install 1,000, 2,000 absorbers all concentrated in one place, I could imagine that there would be a effect on the immediate local environment. But that's not what we're aiming for. If you want those quantities of water, it's better not, that is not the way to go with, maybe in like 100 years when it's super cheap, but I don't envision that right now. And so that is really not our worry. And it's sometimes in a strange way, if it does influence, we are taking H2O out of the air, which is a greenhouse gas, so we can like balance it out with global warming. No, I'm just joking. But that is also basically that short answer is no.
And what are the questions you usually get from local partners when you introduce them to your technology?
Some people get confused on the remineralization. That's a quick one, of course. Like they don't keep in mind I often have to do this presentation in Portuguese or Spanish, which I can get around with, but sometimes of course there is some miscommunication. And I remember we had a meeting once and it was a long one, and at the end they kept thinking that our system produces pure H2O, which is fine for some cases, even for high-tech agriculture where they want to control exactly what goes into the water and green hydrogen. But no, like the main thing that we're targeting, we do have a remineralization process where we add a concentrate of the basics that you need to have in drinking water to make it healthy, to make it taste like drinking water, and to keep the like magnesium, calcium, all those little elements. But that, and then also, let's see, another question that we get quite often, when we get energy supply, because that's also can be confusing, either solar thermal, PV, what are we doing? The whole thing is that it's mainly the focus is thermal energy. It's just simply more efficient in our system, the way we've designed the system. But there are situations, for example, some of these places we've been looking at, they don't have a water grid, but they have an electrical grid. And in Brazil, for example, 80% of the electrical grid is hydropower. So they're kind of at ease with using electricity. It's not like they really want a solar thermal field. So that is something to think about sometimes. It'll depend on the use case, of course. And I can't think of anyone other right now, but it's usually along those lines.
So good, just to get a good picture. Any other questions? If not, then thank you, Pierre, for giving this nice talk. I wish you much success with your company. And thank you everyone for participating. And then maybe this is also a good time to mention that this is the last Acting for Water talk this year. We will continue in January and February with the last several more lectures. I believe we have one planned on 22nd of January, but please keep an eye on the website when the new lectures will be planned, and then you can register on the website and for water.eu. So thank you very much.
Okay, thank you very much, everyone. Thank you very much, Acting for Water, Katarina, Martin, everyone for attending. And yeah, wish you all the best for the end of the year, and I hope to keep you in touch with our progress.
Yeah. Thank you very much.
Bye-bye.
Bye bye.
Bye bye.